Hey, everybody. Welcome back to the Simply ICS Cyber podcast. I'm Don C. Weber, the cybersecurity guy.
And I'm Tom VanNorman, the ICS guy. And today we have Chris Sistrunk from Mandiant Google Cloud Security. We're going to talk about some substation security. Chris, you want to give the audience a quick introduction?
All right, sounds good. Thanks for having me on. My name is Chris Sistrunk. I'm been part of Mandiant on the OT team for over 11 years, doing ICS OT assessments around the world for critical infrastructure folks. And then before that, I was electrical engineer at a large electrical utility as a SCADA substation engineer. So glad to be here, y'all.
Excellent. Hey, Chris, thanks for joining us. I mean, most people in the ICS OT community know you. You've been around the block, I guess, so to speak, but certainly from a OT cybersecurity standpoint, you've definitely shown me the way in a lot of things, and I really appreciate it. But you know, one of the things that kind of attracted us to inviting you to this is the fact that y'all came out with something unique and different as far as publishing some information. So, you know, the Substation Security blog post that was recently released a couple months ago at the time of this recording. I'm not even a couple months ago. I think it was last month. So wanted to come in, you know, what was that blog post covering? You know, can you help us understand what was in there? What was the intent, and your thoughts around it?
Okay, sure. So for those of you who haven't read it or heard about it, you know, we have a threat intelligence blog under Google Cloud Security, and Mandiant's part of that. So our Mandiant OT team has been doing substation security pen tests, red teams, and physical pen tests many years with different electric utilities around the world. And so we felt that it was a good time to do a deep dive in how to protect substation relays. And, you know, because there's a lot of things that we have found and learned over the years doing red teams against these. And what we've learned is, you know, not only how to perform attacks on them, but also how to defend them. And that's what was a big win for our customers when we did these assessments. We helped them lock down things that they previously hadn't had a chance to lock down. You know, the focus is usually on segmentation, right, in these environments.
So it actually goes into the devices that are implemented within those substations, not just the network components, but the actual relays and controllers and protections devices. Is that what you're talking about?
So yeah, the name of the blog is Protecting the Core, Securing Protection Relays in Modern Substations. So I know you both have been in substations before. For the folks that are listening, you know, you drive along the interstate and you may see the big power lines, and you see electrical power lines coming into a fenced area with a lot of big equipment. And that's generally what we call a substation. And you have like transformers, circuit breakers, transmission switches, distribution feeders, insulators, you know, all different types of system equipment that makes a substation work. That's part of the overarching grid, even if it's a local transmission or distribution grid or a larger grid. So part of that, circuit breakers, you know, open and close to like turn on and turn off power lines. And that's, you know, over 100 years we've had that. But protective relays take a look at the electrical signals on those power lines, and we try to use those relays to detect a fault, like if a tree fell on a power line, or there was lightning, or if there was some other kind of damage to that power line. Squirrels. That's the number one threat right there. And so you don't want the power line to burn down. You want to, that's a big expense. You don't want the substation equipment like a transformer that costs millions of dollars to burn down or get a fault where something fails. And so these relays work in a way to protect that equipment and also to isolate the fault and also to restore power to the lines and feeders and things like that. So a substation protection relay, we go into, what it is, where what kind of the things that it has, and we talk about the different types of protection relays, like a distance relay or overcurrent relay or a breaker failure relay component, which used to be a standalone electromechanical device in a substation. Now, due to the invention of microprocessor-based relays in the early 80s, a lot of these have multi functions inside them, and they're all digital, which also means they have ports where you can talk to them, serial, fiber, or even Ethernet. So
so Chris, in a substation, it sounds like there's a lot of different hardware, or different technologies rather. The substations, are they isolated from each other? How does that information get out?
Yeah, it really depends. And, older substations, they may not be networked only for the relay part of it. They may not be networked at all. But for the SCADA system, supervisor control and data acquisition, the substation RTU remote terminal unit, that will have a connection. And SCADA has been around a long time, since the 40s. And so SCADA systems aren't always connected digitally to protective relays. But as we've gone over the last several decades, they've been increasingly connected. So they're depending on where you are, if you're electric utility or if you're, say, let's say a large user of electricity, like a data center, you have substations there. You have like a paper mill will have its own substation because they have a generator there and they have to get power from the grid. So it's not just electric utilities that have these substations. It's anywhere there's a large use of electricity. So like even the refinery, like in the video on the background there of the podcast, it's refineries, any large, like a port will have a substation.
So it sounds like some of these could be highly automated, highly connected, and others are not. Mm-hmm. In the research that you guys just released, how do you defend the substation against an adversary that you identified?
Yeah, so coming from our perspective, we have a red team. If you don't know what a red team is, we attack a substation on purpose. They hire us to come in and do an attack on the substation, simulating an adversary, what an adversary might do. And we've seen power grid attacks come up in the last decade, especially in the Russia-Ukraine war, right, where Russian groups that are tied to the military intelligence, GRU, they are attacking substations in Ukraine. And so, but also we've been doing research, in the United States for quite a long time around this, like back to 2007, the Aurora vulnerability that was discovered, that Mike Asante and them. So what we wanted to do is take these lessons learned from all these red teams that we had done, and then communicate that to the world through this blog. Because if we can describe the ways to attack a system, then we can be a better defender of that system. So we can put on our evil hard hat, per se, and to better protect our critical infrastructure like a substation, let's find a way to attack it. Let's defend it by learning its weaknesses, and then sharing that information. And that's what we did in the blog.
Yeah, and looking at this right now, down towards the end of it, I mean, it does a great job of describing the technologies and some of the concerns around some of the devices that are in there. I see the top 10 security practices for that. And one of the things that I think of, you made reference to the background, the power plant. Certainly, there's just about everywhere I've gone, from refineries to smart buildings to data centers and so forth. There's typically some type of switching infrastructure within that environment because, while the grid is stable, they still have the responsibility of protecting equipment, ensuring service under certain conditions. And so some organizations might have their own substation in addition to the substations that are provided by the local utility. So in my mind, when I'm thinking about this kind of applies to those organizations that are implementing their own infrastructure, in addition to a utility. Is that accurate? And what are some of your kind of experiences around that?
Yeah, absolutely. So, NERC-CIP is, in the United States, is in North America, Canada as well, has done a great job of communicating how important it is to secure these systems, especially on, bulk electric systems, the high voltage transmission systems, and the ones with a lot of load. So larger generation, the larger distribution. But outside of NERC-CIP, you may not have regulations around that. And so they could be weaker in their defenses. Well, that's why we kind of wrote some of these top 10, because we followed in a nod to the top 20 secure PLC coding practices that came out. That some of us, I think all three of us, worked on that in some way or fashion. But we wanted to come up with a way to, hey, these are some things that you can do to help protect your relays with cybersecurity in mind, even though you may not be required to. And then, we dig in the blog of going down the attacker life cycle. Some people call it the cyber kill chain, from reconnaissance all the way down to physical access. Like, how would we attack these systems with each step of the attack life cycle, and then how we would defend it. It talks about how we would defend against some of these in each section. But I can elaborate more if y'all have specific questions. But that was like the big win there. Like, we were getting this information out into the world, really had never been talked about. SANS ICS asked me to write a 2-part blog about this 10 years ago, for attacking. How would someone do a cyber attack on a power substation or distribution or transmission substation? So this really, really expands upon that to very high technical degree.
We will definitely mark that blog in our show notes here for the audience to go reference back to it.
Yeah. And also too, this, a lot of the stuff your relay engineers may already know. There's a lot of good documentation on how to secure these, and the manuals from vendors like SEL and GE and ABB or Hitachi Energy, things like that.
Yeah, I mean, Chris, I mean, that's a good point. I really think kind of the issue here is that, for the people that I've talked to in the industry, they kind of know some of this stuff, or they know that they should be doing it. However, the big challenge is once this stuff goes in, changing it, doing all of that, redoing all of that site acceptance testing and ensuring that it's not having an impact. What have you seen? What has been the approach of some of your clients to actually get these rolled in and getting these improvements where they're important?
Yeah. So again, when we do an assessment, usually, we have a defined scope and we always have rules of engagement. And we have done these red teams in live substations, like with live circuit breakers in live lines. And so where we show that we could take control of the command line, like of the relay itself, even though that they had other security mitigations, we showed them what the weaknesses were and then how they could improve that. And so, yes, there would have to be some redoing of some factory or site acceptance tests or commissioning, but it's really not a point-to-point system. It's more of making sure the firewalls that segment these things or the default passwords are changed. So some of these may not be related exactly to an engineering change, like to the substation one line diagram, like what are the settings of the relay itself. So there's a lot of making sure that the systems around the protected relays are protected and secured. Because let's be honest, if you're in a substation, all bets are off. So,
Right. Physical access wins, right? Every time.
Yeah. And we actually call that out too. It's like, you could go to SEL relay and pull the password jumper, put the password jumper in, but you actually have to power cycle it. So that would be noticed pretty, like the SCADA alarms would be going off because someone powered off the relay, and these things are common sense, but for some areas that maybe it's a new data center, maybe they haven't had the rigor that electric utilities have had for the last 20 years, they may be having to catch up. So,
Chris, so the blog, does it make a difference if the person reading it is in Europe or Asia or North America? Is it written for one part of the world? Where is it?
It's written for all. So we didn't even mention NERC-CIP in the blog. Like we do mention the different protocols, like IC 61850, which is used widely, not really as much in North America. But we do try to make it deployment agnostic. Where
Yeah, our podcast does go globally, so it's great that somebody in Asia can pick it up and get something out of reading your blog, as well as somebody in North America.
Yeah, we also talk about we also talk about IEC 6875-104, 101, 104. Like in the United States, we use DMP3.
Okay.
Over there, or other places, they use IEC 104. And IC 61850. So we really do cover those things. And to be honest with you, a lot of the vendors have like very verbose sections on securing their systems, but not that those manuals aren't always available to the public. You have to have that equipment and have a access account, like with SEL, to get an account, to get the manual. So again,
where I see this is really important, Chris, is that it's not always that the vendors are implementing these. In other words, the owners and operators that are purchasing this, if they're a utility, even if they're a utility, they might the smaller ones, they might be contracting somebody to deploy these technologies. When we're talking about the power plants and data centers, they're more than likely interacting with some type of integrator. It might be that vendor, but a lot of times it's some integrator that is just familiar with that vendor's product. So where I see this coming into play is those cybersecurity programs that don't do electricity for a living, being able to build requirements for those integrators, at the start of their contract, or when they're coming up with renewing their maintenance agreements. This can play into building some of those implementation management requirements. Have you seen this being used like that?
Yes, absolutely. I know. we have a whole relay team at Google with all of our data center substation. Like, it's a huge department. And so we even have our own SCADA relay test lab, which is really awesome. And I imagine all the other large data center companies probably do as well, because they might have had issues in the past of using a contractor and having issues. I don't, not pointing any fingers at all, but those have happened. There's been even with electric utilities using a contractor, sometimes you have a mismatch of some kind. I know for a fact, like, of an outage at a substation where they had a color code mismatch on the wiring for the relaying, and they didn't have the knowledge from the old wiring code from like 1965. So they didn't know that the new wire code was completely opposite of an old wiring code that wasn't communicated to the engineering design team. And when they wired it up and tested it, boom, they had an outage because of this issue. So, it's human error finds a way to that's the number one threat, really, to control systems overall, besides squirrels. And having including security, injecting security best practices into even substation relay configuration and engineering, it is something that we really want to help push that message out there.
It's definitely something that we need more information out there. We hear about all the adversary groups like Volt, Typhoon, now we're Black Energy, and the list goes on and on about adversaries doing stuff or trying to do stuff against our power grid. So it's great to see that a blog will go out, but not on not a report on a attack, but on a potential attacks or what is possible. Right? You guys were not.
We actually in the blog, you'll see we have attack vectors for a particular protection relay, and it's a mind map, and it shows you all the ways that you could attack that system in the context of if you just had access to that relay device itself. It ignores the external context. Okay. So, like, good physical security and having segmented networks and XYZ, security. So,
Chris, something we haven't talked about, does green energy fix all of this? We don't have to worry about this if we go to green energy?
Green energy still needs protective relays.
What?
And yeah.
What happens when the sun goes down now? Do you need protective relays?
You have to have others. You have to have multiple sources of power. So, or batteries. Get Dr. Emma Stewart on here. She'll talk to you all day and all night about batteries.
Oh, absolutely.
And it's like I think the future demands on the grid. Expanding the topic a little bit. I just saw in the news that I think in the state of Wyoming, there's going to be more data center demand for their power grid than there actual is from customers.
The people,
yeah. So, like, I know Meta's putting in like a 4 gigawatt data center in Northeast Louisiana, or it could be up to 4 gigawatts, I think. Correct me if I'm wrong, but it's like now the power company's going to have to build several more power plants to deal with that demand. Yeah. And so we're going to have more relays than ever before. And there's going to be more opportunities to get things right or get things wrong. So let's make it like safety culture. Let's build in security into the culture that we built with electric utilities. And, the ones that are under NERC-CIP, y'all are doing a great job. Even NERC-CIP, the new internal network security monitoring, NERC-CIP 15 this will help that out a lot. I remember Nathan Wallace and doing some of this stuff with his relay test bed at Distributech with several other folks. And they were able to say, hey, we had an alarm on the relay if the door to the cabinet was open or if it logged in the second level of the password where it pulsed the output 101 alarm contact. And so, like, if those things pulse and no one's supposed to be out there working, that's like a trigger, So that, there's a lot of stuff that's people have done. They just haven't talked about it publicly. So hopefully this will generate more discussion, even internally and privately at companies. I've already had several engineers at power companies message me directly, say, we love this blog and we're using it in our training.
So Chris, you mentioned something interesting just a few minutes ago. Well, over the last 26 minutes, all been interesting. But to put things in context for our viewers, you talk about somebody building a 4 gigawatt substation in northern Louisiana to power data centers. Let's put that in perspective here. 4 gigawatts is 4 billion watts of energy. Okay. How many power plants, and you are at a serious disadvantage than I am because I got Google right now, unless you're Googling the same thing. How many power plants in the U.S. are over that right now? Do you know?
There's none. Unless you have groups, like not a single unit is over that. Like the largest single unit is actually at a nuclear plant in Mississippi. It's a Grand Gulf. It's like 1,500 megawatts or 1.5 gigawatts.
Yep. So we have several that are combined output, but none of them that are a single output. So we talk about 4 gigawatts of power. We're not just building a substation or data center. We're building power plants to power that thing. Where I'm in Pennsylvania, they're recommissioning 3 Mile Island to power a Microsoft data center, and up north here in Berwick, Pennsylvania, Amazon building a data center to connect right to the nuclear generating station there. So 4 gigawatts is a lot of power.
Actually, I was wrong. I pulled up the link. It's actually 5. It could be 5.
5. Okay.
So, because
that makes your problem better, Chris.
Just another million. Just another. So it's such a big deal, and that's like we're getting into nuclear. It's like Google has partnered with, like, I think Kairos Nuclear Energy to build small modular nuclear reactors. And several other data center companies are as well. So I think,
we're better at that than 3 Mile Island, the original 3 Mile Island. We're better now. I mean, science. I think,
right? There's a lot of. I'm not a nuclear engineer, and I don't pretend to be one on Facebook, but I do know that the newer technology has already been researched to the nth degree by many around the world, and it's just a matter of who can do it first, and then it's going to be ubiquitous. I think.
I also think it's public opinion, especially here in the United States. Public opinion. I mean, we've been burned so much, and a few instances, and everybody thinks back to Chernobyl. They think that that's still possible and still a risk. So it's kind of a PR thing. So we'll see those changes.
I do highly recommend your viewers to go watch this series from Destin Sandlin at Smarter Every Day on his YouTube channel. He's got 2 or 3 videos of about nuclear energy, and he goes into a nuclear plant, I think one of TVA's nuclear plant, and he shows like how much REM he's getting, that he's allowed to get per day, per lifetime. And they compared it to how much a X-ray tech gets, and it's not even close. Like, it's teeny tiny amounts that a nuclear reactor employee gets compared to, someone who works with X-rays all the time.
Interesting. I'll find it and I'll put it in the show notes for everybody. Yeah. Hey, Chris, we're right at the end. I don't want to belabor it too much, but where can people find you, Chris?
Well, you can find me on LinkedIn, Chris Sistrunk, or I am on other social media sometimes, like Blue Sky. I'm on Mastodon, but I don't post there much. But or you can send me an email, Chris Sistrunk at google.com for work, and be glad to hear from you.
Awesome. Well, we really appreciate it. Hey, Tom, any outward comments?
No, Chris, has been great chatting with you for the last half hour. Look forward to seeing you at upcoming conferences and whatnot. And thank you for taking the time out today to talk to Don and I.
Yeah.
Yes. Good to
Really
see you.
appreciate it, Chris. Yep.
Now,
Awesome.
Now Don can go hack power substations.
I already do, man. All righty, brother. Hey, thank you, everybody. And thanks for joining us on the Simply ICS Cyber podcast. We'll see you next time.
Thank you.